Hello, hello, hello. Welcome back. I know I said this would be my last, well, the last one where I did it online was going to be my last solve before the actual ESAT paper. I lied. Sue me. There's a couple reasons why I wanted to come on real quick. The first is that I got a comment requesting 2023, and so I thought I'd get that out just in time, just in case that would help some people. Second reason is one of my students had an interesting issue with his approach and mindset that I thought would be helpful to share to a wider audience, where I thought there were 2 points to make. The first was that his speed was perfectly fine, but I found that he was overworking it and ironically pushing his brain into a state where he was creating noise where there didn't need to be. And so I've been coaching him to slow it, well, not slow it down, keep the same pace, but keep the voice very calm, very still, very lazy. It's just this, it's just that, because that way the really clear solution paths can make their way to the front. And the second point that I thought was very interesting for him was he was a perfect case study for why the first question sets the tone. The reason why you've got to do these multiple passes is because if you get into the first question and then you trip up on it, you take 3 minutes on it, and you get an answer that isn't even one of the answers, so you know you've done it wrong, and then you skip it, knowing that's behind you, it really doesn't set you up to do your best work through the rest of the run. So I've been really coaching him on finding the first question and making sure it's really good for setting the tone. And we've been quite ruthless because the temptation is really not to skip at all, because it feels like giving up on it, which gives that feedback of, oh no, this is going badly, I'm having to skip so many questions. But for him, I've been advising, don't even think of the first pass as like skipping bad ones. You're not skipping because you can't do it. The first pass is bonus. So if you imagine there's like a sort of game where there's like a multiplier run, and you're just hunting for the quick gains. And so that's what I'm going to try and demonstrate, those two things. One is being very selective about my first question, being ruthless with my skipping. And two, keeping the pace, but keeping really calm. Because I think, in fact, I even did that. You can see it in my first run where I was kind of like overthinking, working a little bit too hard, and then tripping up as a result, not paying close attention to my exam technique. So I think at this stage, right before the exam with the day to go, I'm just going to keep myself calm. And we're just going to go through 2023, and it's going to be okay. Ooh, while I remember, there was another comment on my first video about the 2022 run. Question 31, I actually got incorrect. And I looked up a mark scheme, which said I was also correct. And we were both wrong. And a commenter pointed out that and you can look it up, I've made a correction in the description there and in the comments there, saying that I'd actually just worked out the resultant force when I needed to go further to work out a specific individual component of that resultant force. So with that out of the way, let's get into it. So I'm going to move you over here. Let's start sharing screen. Hold on a minute. Let me get rid of the get rid of those. Make it nice and clean. Okay, now this is going to be 2023. I think I've been through the physics with someone, so that's not going to be super fresh, but the math 1 and math 2 should be good blind unseens. I'm going to do the same thing as usual. I'm going to go from the back to incentivize me to really skip and think about what I want that good first question to be. I'm going to keep my split times as usual. We know the drill at this point. So with that said, I'll start the clock. Not the first question. Also not the first question. Yeah, go on, I like that. Okay, so the second term of an arithmetic series is a plus d is equal to twice the 8th term, which is a plus 7d. So 2a plus 14d. So moving that over, a equals minus 13d. So the 5th term is 9 over 4. So that's a plus 4d is 9 over 4. So minus 9d is 9 over 4. Cancels, cancels. And d equals minus a quarter. So a is 13 over 4. The 20th term is a plus 19d is minus 6 over 4 is minus 3 over 2, which is c. And that is the 20th term. Yeah, so C, final answer. Next. No, lap. Okay. I like that as the first question. So, these are the endpoints of a line segment. P has that coordinate. P has such as. I can do this. So 17. So P lies on. Let's just draw it. Let's just say that's P. That's minus 8, 5. That's going to be x, that's going to be y. I don't really care where they are. X to p is 4 minus 3. So that must have started from minus 12, because I had to go 4 to get to minus 8. And it started at 8, because I had to go minus 3 to get to 5. That's 1 to 2. So I know that vector is going to be 8 minus 6. So if I go there from here, that's going to end up on 0 minus 1. Point Q is such that QY is 7, 8. So that means from Y to Q, the opposite, I have to go minus 7, minus 6. And I'm going to end up on minus 7, which is E, which is Q. Lock it in. Okay, keeping it calm. One question after another. What is the smallest value of that? The smallest value of that is when this is the most, and I'll zoom in so you can see the power a bit better. The smallest value of that is when the power is the most negative. In other words, what is the minimum point of that quadratic? So the minimum point, as usual, I'm just going to complete the square on that. Plus 3 squared minus 9 plus 7. So it's going to be x plus 3 squared minus 2. So the minimum value of that is minus 2. So 10 to the minus 2 is 0.01, which is B, final answer. Okay. Okay. So 15. That equation. Okay. So what I'm going to do here is I'm going to bring these to the same power. So that's 10a plus 2a is 12a times 10 to the 3, all over 3 times 10 to the minus 1, which I'm going to simplify to that. It's going to make that 10 to the 4. And so it's going to be 4a times 10 to the 4 squared is 8 times 10 to the 9. So 16a squared times 10 to the 8 is equal to 80 times 10 to the 8. Cancels, cancels. So a squared is 80 over 16, which is 10 over 2, which is 5. And a is equal to plus or minus root 5. And the difference between those is going to be 2 root 5, which is B. Okay. So 14. Okay, I know how I like to do this. So for 14, y is inversely proportional to the square of x. Z is directly proportional to x. So what I'm going to do is I'm going to make x the same. So if that's directly proportional, I divide both by 2. I know z is going to be 0.6 for x equaling 3, which means that z equals 0.6 when y is equal to 20. And I know that y is inversely proportional to the square of x, and z is directly proportional to x. So I know that y is inversely proportional to x, z squared. So that tells me that y1 z1 squared is y2 z2 squared, which I know from my physics. So 20 times 0.6 squared equals y equals 80 for the new z squared. Cancels, cancels for 4. So 0.6 over 2 squared is z squared. So z is 0.3, which is d. Okay. Love similar objects. Okay. 13. Two objects are similar surface area. So I'm just immediately, we have x and y. I'm going to blindly just do length, area, volume, and let's see what's up. Surface area of y is double, so that's a 1:2 ratio in surface area, so it's a 1/√2 in length and 1:2√2 in volume. So I know that volume of y is 2√2 the volume of x, but the volume of y is also equal to the volume of x plus 7√2. And we want to solve for x. So the volume of x into 2√2 minus 1 is 7√2. Let me just scroll up so I have room for this. So is 7√2 all over 2√2 minus 1, and then I'll do 2√2 plus 1, and 2√2 plus 1. So on the top, I'm going to get 14 times 2 is 28 plus 7√2. Bottom, I'm going to have that squared is 8 minus 1 is 7, which is going to be 4 plus √2, which is h. Okay. So 12. The line joining those points is perpendicular to the line with that equation. Right. So that means that 4y is equal to 3x plus 5. Y is 3/4 x plus stuff. So m is equal to 3/4 on this line. And if it's perpendicular, the perpendicular gradient I'm looking for is minus 4/3. And that is the gradient of this thing. So I'm going to change in y. So that q minus 4 minus that thing is going to be 2q minus 6 all over q plus 2, which I get from subtracting the x ones. That's the gradient, which is minus 4/3. And we can solve for q. So 6q minus 18 minus 4q minus 8. 10q is 10, so q is 1, which is C. Hope I didn't make any execution errors there. Right. 11. Several complete repetitions of a 3-part program. Average speed for the complete training session. Well, average speed is total distance over total time. So I have to work out the time. It's in kilometers per hour, so let's keep it in kilometers. So distance equals speed times time. Time equals distance over speed. So 0.1 over 6 for the first one. 0.2 over 10 for the second. 0.1 over 20 for the third. So we have to add those all up for the total time. Which I don't really like. I might come back to that. Let me skip that one. I should know myself. I know I hate speed questions. Come on, I knew better than that. All right. But I can come back to that. Two angles are 90 and theta, where tan theta equals √2. Let me draw a triangle where that's the case. Opposite over adjacent, so that becomes √3. And that's 90. The length of the hypotenuse is 3√6, so I'm going to have to scale that up by multiplying by √2 and by 3. 3 times √2 on this is 3 times 2 is 6, and that's 3√2. The area of the triangle is 1/2 times the base times the height. Cancels, cancels. For 3 is 9√2, which is B. Much better. Okay, 9. Last year, the salary. Okay, so let's do, so last year, the salary of the coach was 4/5 X, where X was the salary of the star player. At the start of the new year, coach received 15% increase. So that's 3/20ths more. So it's 23 over 20 of his original salary is where he goes to. And the star player went from, so it was that to that. And the star player went from X to 1.38x. So that's 69 over 50. Lots of X is where he's gone to. So percentage of it as the coaches. So the new, well, cancels for 5. So it's 23 over 25 as a proportion of 69 over 50. Well, I'll double that up actually. So it's 46 out of 50 compared to this guy's 69 out of 50. So it's 46 69ths of that. And 23 is a factor of both, so it's 2/3. So 66 and 2/3 is D. Okay. Eight. Solutions of that are P and Q. Where's volume 3? Just find it. Does that factor? 6 minus 6. Doesn't look like it factorizes, and I'm seeing square roots. Okay, so let's say that the solutions are x is equal to 6 plus or minus square root of b squared minus 4ac. So that's plus 12 all over 6. So that's 6 plus or minus the square root of 48 over 6. 48 is 16 times 3, so 6 plus or minus 4 root 3 over 6. So I'm going to call that 1 plus or minus 2/3 of root 3. P is bigger than Q, so P is the plus case. So 3P plus 2Q. Well, I also know P plus Q is equal, well, let's do this way. P plus Q, the minuses will cancel. You're just going to get 2. So it's 2 lots of those for 4 plus a final P. Plus 2/3 of root 3. So it's 5 plus 2/3 of root 3. Which is not an answer. No, don't waste momentum. This is a first pass. 7. So given that, okay, so that's going to be 3 to the 6 x minus thingy stuff, and that's going to be 3 to the 2 of the stuff is equal to 3 to the 4 times 3 over 2. So 3 to the 6x minus 2 all over 3 to the 4x minus 6 is equal to 3 to the 6. So that's 3 to the, because you subtract the powers, 2x, that minus that is going to be plus 4, is 3 to the 6. So 2x plus 4 equals 6. 2x is equal to 2, x equals 1. Seriously? What am I doing? Hold on. So that's 3 cubed. So that definitely rates 6. Because I forgot to multiply that out to 12. Okay. So that minus that minus that gives me minus 6. So 2x minus 6 is 6. 2x is 12. X is 6, which is D. Woo, good catch. Okay. Nice and calm. So 6. Always factorize fully on these because things are definitely going to cancel. So that's x plus 6, x minus 2. Keep, change, flip. Take an x out of that. You get x squared minus 36, which is x plus 6, x minus 6. All over x minus 6. Cancel, 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 cancel. 4x, x plus 6 all over x plus 6. Oh, that also canceled. So it's just 4x, which is D. Okay. Up too far. Right, I'll scroll down for the answers later. So on 5, what have we got? Side length 1, I can't annotate. Well, you can't annotate. So I also won't annotate side length 1. WM to MX is 1 to 2. So that's 1/3, 2/3. X, and so that's 3/4, 1/4. That is 4/5, 1/5. So the area of the triangle, what I'm going to do is I'm going to cut this off and split this into 4 shapes. And I'm going to knock off A, B, C, and D. So the area of the full square is 1. I'm going to knock off this guy, which is 1 times a fifth is a fifth. This guy, well, actually, no, let me not do that. I prefer area of a trapezium. So that is going to be half times the average of the parallel sides. So half of a third plus a fifth times 1. So 5 and 3 is 8/15. So that becomes 4/15 in this region. So this is a half base times height, which is a quarter. This is a half base times height, which is a half of base and height. Cancels is a tenth. Minus 4/15 minus a quarter minus a tenth. Get these all over 60. 16, so multiply this one by 4 to get it to 60. Multiply this one by 15 to get it to 60. Yeah, multiply this one by 6 to get it to 60. Minus 31, minus 37, so 23/60, which is F. Okay, that took a little too long. Okay, we're nearly there at the end of the first pass. Increasing order of that. Mean of the 6 numbers. So 2 plus 2x plus y plus, that would be, let me zoom in a little bit, plus, well, that would be 51. All over 1, 2, 3, 4, 5, 6 is 12. So 2x plus y plus 53 is 72. 2x plus y, plus 20 minus 19. The median of the 6 numbers, 1, 2, so x plus y over 2 is 7.25. So x plus y is equal to 14.5. Let's subtract these two. That means that x is equal to 4.5 and y is equal to 10. So the mode of those numbers is x, which is 4.5, which is A. Okay. Keep it nice and calm. We've got about 10 minutes left. For 3, rearrange that. So y is equal to ps minus px minus q plus r all over s minus x. Sy minus yx is ps minus px minus q plus r. Make x the subject. All the x's to one side. So I'm seeing p minus whatever. So px minus yx equals ps minus q minus r minus sy. So we have p minus y into the stuff. So x is p s minus ys minus q minus r all over p minus y, which is s into p minus y all over p minus y. Sorry, that was a plus r. minus Q minus R all over P minus Y. So it is S minus P minus Q over P minus Y. I think the answer is C. Okay. Which of these are correct? So 47 over 93 times 71 over 33. 71 over 93 times 47 over 33. That is correct. That's meant to be, you know what I meant to say, 47. So that is correct. The second one is definitely correct. Because it's, yeah, the over 100 just swaps over. That's fine. That doesn't look correct. So that goes in to make 12. And that goes in to make 18. So 1 is correct, 2 is correct, 3 is not correct. It's 1 and 2 only, which is E. Okay. We have a comment. What's the longest time you should spend on a question before abandoning it? Sometimes I know how to solve the question. I would say that if you're in that case, second pass it. First pass is for the first building up a time bank and building confidence. So the surface area of a solid sphere of radius r. Surface area of a solid sphere of radius r is 4 pi r squared, is equal to the total surface area of 10 solid closed cylinders. 10 times the surface area of a cylinder, which I know is 2 pi r squared plus 2 pi r times the height. This is interesting for a first question. 10 into 2 pi r squared plus 8 pi r squared. So it's 100 pi r squared. Cancels. R squared is 25 r squared. So big R is equal to 5R, which is A. Okay, so first pass done. 6 minutes 40 left. Let me go back and mop up any of the ones that I either couldn't do in the first pass or could do but would take too long. So if you know it's taking about 2 minutes, that's when I'm going to leave that. So let's go back and mop up any flagged questions. So 2 bags contain counters which are identical except for color. First bag contains 3 blue, 2 yellow. X red, 1 blue, 2 yellow. Counters picked from random from the first and placed in the second. Counters then placed at random for the second. The probability is yellow is 0. Right. So how do what is the probability that this counter? Okay, so how do I get a yellow? You either, it's one of two cases. You either pick a blue from here and then a yellow from here. So 2 over x plus 3. Or I pick a yellow from the first, and then there are 3 yellows in the second one. And that probability is a 5th. So I'm going to multiply everything by 5 straight away. 6 plus 6 is 12 over x plus 3 is equal to 1. 12 equals x plus 3. X equals to 9. So there's 12 overall in the second bag. Second bag. So it actually doesn't matter. Whatever happens, whether it's blue or yellow, the probability will be 9 over... Oh. No, it's over x plus... Oh, I've done this wrong. Sorry, there were x plus 3. There are now x plus 4 in the second one. So x was actually equal to 8. So there were 8 red. So once I take one from there and put it in there, there's 8 out of 12, which is 2/3, which I'm going to say is E. See, because I'm thinking calmly, I'm able to catch these things without panicking. So here at 19, got us 4 minutes left. I'm not going to get 100% on this run, but I'm calm, so that's fine. So that is 2. Okay, that is 2/3 to the sine x. And the maximum that's going to be is when sine x is equal to -1, because then it'll be 3/2. And that will be, oh, 3/2, bam, C. Okay, done. I've done this. Done it. Done it. Done it. Done it. Done it. Done it. Speed. Okay, let me go find 11. Okay, so that's the total time. Let me keep going on this. So I've got 3 minutes to solve this now. So I think there's another one up ahead as well, but oh, let's make this all over 30, of course. So multiply this by 5. So 0.5 over 30 plus 0.6 over 30. Oh, I should have made them 60. Oh well, I'll do that now. So multiply by 10. So it's 1 over 60 plus 1.2 over 60 plus 0.3 over 60. 2.5 over 60 is the in total time in hours. So speed equals distance of 0.4, total distance over total time. So put the 60 on the top. So that's a 2.5. So let's multiply all of these by 10. So that's 25. So it's 240 over 25. No, I shouldn't have done that. Let's cancel 5s. So 5 and 12. So it's 48 over 5, which is just shy of 10. So the answer on 11 is B. Okay, let me keep going. I've got 2 minutes left. I got that one. I got that one. 8 I didn't get. What went wrong there? Let me redo 8. I've got 2 minutes. Okay, so. No, let's not redo it. The work I did was good. So let me find my working. So here, minus b plus or minus square root of b squared minus 4 AC. Sorry, that should have been 24. Making that 60. What can I take out of that? I'm not sure I can simplify that super easily. Okay, so it's 1 plus or minus a 6th root 60. The point still stands that this plus this, so it is 2. I maintain that this is correct. So it's 2 plus 1 plus root 60 over 6. And there's a 2, you can take a 4 out. So it's 3 plus root 15 over 3. No, 4. So that's 5 plus 5 plus, so that's E. Bam. And now I've got 45 seconds. I don't think I'm doing anything meaningful here. But let me just check. Got an answer. Got an answer. Got an answer. Yeah. 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 Woo! Okay. So I actually did submit answers to all 30 questions. Well, 20 questions. Hopefully that gives you a sense of, as well, how to keep your cool during a run. Just don't let it bother you, and you can probably get there by the end as long as you keep your cool. Let me check the answers first of all, and then we'll analyze my splits. I anticipate there probably are a few execution errors, but hey, we'll see. So I started on 18. No spoilers for the physics, please. So 18 was C. Yep. 17E. Yep. 16B. Yep. 15B. Yep. 14D. 13H. 12C. 11B. 10B. 9D. 8E. 7D. 6D. 5F. 4A, 3C, 2E, 1A, 20E, 19C. Boom! Nailed it. Oh, that's a good feeling. And you can see that run wasn't going super well. Like there were moments where I was like, "Ooh, that's a bit dodgy," but I trusted the system. I just sort of went, not first pass, not first pass, because I know how it works. I'm not going to worry about anything that happens in the first pass because I can mop it all up in the second. Also, there was a comment, and I know I mentioned it at the time, but I was kind of like in the zone, so I didn't spend too much time on it. So the comment was, "What's the longest time you should spend on a question before abandoning it?" Sometimes I know how to solve the question. It's just taking me approximately 2 minutes. So the way I advise people is, in your first pass, you should only be doing it if you know that you know how to do it and you know how to do it quickly. So if there's any sort of guess, like sometimes, for instance, I should have known that I don't like speed questions because they just take me a lot of time and I have to kind of think about them and work them out. That second pass. Alternatively, some people take the series questions. They look at them and go, "Oh, I know exactly the steps I have to go through, and I know it takes a long time." In that instance, push it to the second pass. If you know it's going to take some time, you don't want that to feel pressured. So by the end of the first pass, you've got all the quick questions. You've built up a time bank. So now instead of thinking, "I have to get this done in 90 seconds, you think, "I've got a solid 2.5 minutes on this because I've built myself that time that I can afford to spend on that question." So it's all a matter of like front loading the easy, quick questions. So you take the pressure off those because they're fine anyway. And by doing that, that then takes the pressure off the rest of the questions. So it's all about maximizing your marks per minute and maximizing your chance of putting yourself in the right frame of mind to get it right. So hopefully that makes sense. Do I need to particularly go through and explain any of these in a bit more detail? Did I rush anything? So hopefully by this point you're, well, to be honest, this late in the game, I think it's more about exam technique anyway than it is about the sort of conceptual issue. But hopefully this all made sense. So 10 times, so you have the circle on the top, circle on the bottom, 2 pi r h. For that, I'm not going to scroll all the way down to 20. So this, I think, made sense. This made sense. I was just making sign errors because, of course, I was. That's my classic execution error. But at least I was aware of them and I spotted it. So get everything on one line, get all the y's to one side, get everything else to the other, factorize, divide. This, I think I explained. This, this was great. Yeah. So this is a top tip for solving any question, things like that. And you can see I adjusted when I realized I wasn't gonna enjoy doing a third minus a fifth to work out the height of that triangle. So that's why I bailed on that approach. Oh, actually, as we're doing this, I'll go through my split times. So we can see how my strategy kind of like bears out in the splits. So I skipped a couple, got this done in So even after skipping a couple, I got this done in 1 minute 18. So that was a perfect first question. I knew how to do it. I knew I could do it quickly. Stayed calm, got it done, executed, bam. That set the tone for the run. So then it was, I got this one done in 1:19. Where again, a lot of people can mess up with that. But again, just nice, calm, going through the steps. I went, I am safe to go at the pace I need to go at. And actually, by going a little bit slower to make sure I was accurate, I saved myself the time of getting it wrong and having to redo it. So 16, I got done in 47 seconds. So that's good. You either spot it or you don't with that. So minimizing the quadratic there. 15, I got that done in, well, hold on, I've lost track now. 1, 2, 3, 4. This is the fourth split. So that was 109. Where the trick there is spotting, you can bring them both to 10 to the 3. Then I did this one in 122. I really like this method that I use of linking them through the x to then just get rid of it entirely. And here, because x is proportional to z, I can just make that substitution. X is equal to kx squared, and that constant can come out the front. So if it's proportional, if y is proportional to 1 over x squared, then y is also proportional to 1 over z squared. And then at that point, y equals k over z squared. So y times z squared is a constant, which is how I was able to set them equal to each other like that. And then I just rearranged it and got that. 18, 17, 16, 15, 14. So that was the 5th split time. Right now I'm on the 6th split time. So that was 134. So I took a little bit longer on that, mainly just from the, rationalizing the denominator. It's 10. I'm going the wrong direction. Come on. 134. Maybe I shouldn't do these at the same time, but whatever. What this was 106. I think this was pretty self-explanatory. Apart from how I necessarily... Okay, so let's talk about how I did that, because I skipped some steps. Okay, so the way this works, that minus that, so it's q minus 4 minus 2 minus q, which is plus q, so 2q minus 6, which is where that came from. And this 2q plus minus q is equal to q plus 2, which is where that came from. So apart from that, I think it was pretty self-explanatory. Okay, so 11. The 8th split. So I got a minute in and then realized. So this was a classic case of what the comment was about. I knew I could do this, but I discovered it was going to take too long. So I wasn't afraid of abandoning it after a minute, knowing I could come back to my same work under a little less time pressure. Apologies that it's a little messier now. But by the way, that's something you can do on the day. So you're going to have like these like flick books of laminated paper thing. By the way, top tip, they do give you more paper, but only if you ask for it. What you don't want to do is to get to the end of the paper and then have to go, oh, I want some more, and then have to wait a solid minute of doing no work for them to bring it to you. So try and raise your hand and get your paper on your penultimate page, not your final page, just to make sure you have it on hand. And that way you can keep your working to do exactly what I did and come back to it. 10, I liked my method. They love this in Math 1, with scaling the triangles. So that's the 9th split. So that was done in 48 seconds. This was 134. Again, fractions are really, really your friend in Math 1. 8, I got wrong the first time, just made a little execution error. My split times are, to be honest, looking okay. The worst one is the 14th. And I've lost track. All right, I've done my splits the wrong way around. But so the point is, that is how I would advise doing it. Hold on. Question 4, it looks like that was. I took too long on. Maybe not. All right, I'm abandoning the splits time for this run. This is officially becoming unhelpful. But hopefully that gives you a sense of, I think the most important thing was not the split times, but how I managed my psychology, just sort of keeping it calm. I'm going to move on to Math 2 the way they would in the real thing. I'm going to keep doing it from the back just to make it hurt. This time, I'm going to have 15 minutes to answer 10 questions. All right, started the clock. So given that, what's the grace value of that? Ooh, no, thank you. Not for first. Oh, I like these. So the constant term is going to be the on the power of 4, because then I'm going to get 8 C4, 2 over x to the 4, x over 4 to the 4, and the x's are going to cancel. So that's going to be 8 factorial. So 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial times 2 to the 4 over x to the 4 times x to the 4 all over 2 to the 8, that's going to be. Those cancel. That cancels to give me 2 to the 8 down there. 4 factorial is 4 times 3 times 2 times 1. So that times that gives me a 2, which cancels with that. That and that gives me a 2, which cancels with that to make that 2 cubed on the bottom. So let me consolidate this. So 7 times 5 all over 8, 35 over 8, which is B. Apologies for that messiness, but whatever, it worked. So 35. So that plus that, let's consolidate the logs. So log 3 of x squared plus 3x plus 2 all over x squared plus 2x, from subtracting that to the other side and bringing them into the same log, equals 2. That's probably going to cancel. So that's x plus 2, x plus 1 all over x, x plus 2 cancels. So I think I'm going to call that log 3 of x plus 1 over x. I think that's all okay. So then x plus 1 over x equals 9. X plus 1 is 9x. 1 equals 8x. X equals an eighth, which is A. Okay. So you see that first question, I've only letting myself see the easy questions first. So there's a nice smooth path through the run. If it's any way difficult, second pass. It is given, okay, so let's differentiate this. So differentiate is minus ax. Hold on. No, I'm going to rewrite it first. Too much in my head all at once. Ax to the minus 1, bx minus 2, differentiate, minus ax minus 2 minus 2bx to the minus 3. So 2 is equal to minus a minus 2b. That's one equation. Let's double differentiate, and you get plus 2ax to the minus 3 plus 6bx to the minus 4. Put in minus 1. So minus 2, let's put in minus 1 as that. So that would be minus 2a plus 6b. So this minus 1 is equal to minus a plus 3b. So let's do bottom equation minus top equation. That minus that is minus 3. That minus that is 0. That minus that is plus 5b. So b is minus 3 over 5. And a is equal to 1 plus 3b is 1 minus 9 over 5 is minus 4 over 5. And you add those together and you get minus 7 over 5, which is C. Okay. Again, let me just make sure I'm calm enough that everything I do I can stand behind. Okay. First thing I'm seeing here is that's x squared. It's going to be, yeah. So the fact that that's a symmetric integral means I'm going to do that integral is twice the integral from 0 to that. And I'm going to take that outside the square root, x squared dx. So 2 over, and let's rationalize this right away, 3 plus root 5. That's going to be 9 minus 5 is 4. Okay. Then I'm going to get a third x cubed into 3. Oh, not cubed. Okay. So 3 plus root 5 over 2 into a third of 3 minus root 5 cubed. So let me scroll down. So 3 plus root 5 over 2 times a third times 27 minus 3 times that squared, so minus 27 root 5. Plus 3 times that is 9 times 5 is 45. Minus 5 root 5. So 3, I should probably not have first passed this, but I know I'm getting this right, I think. So that led to 60, 72 minus 32 root 5. Cancel the 2 to make that, let me just check that was right. So 60 and 12, yeah. So that's going to become 36, and that's going to become 16. So then we're going to get, oh God, okay, so 108 minus 48 root 5 plus 36 root 5 minus 16 times 5 is 80 all over 3, which gets me 28 minus 12 root 5 over 3, which is E. Yeah, that took far too long. 29. Complete the square. So first we do is we take a root 2 out. We're left with x squared minus, so divide that by root 2. You get 3 root 2. Yep. X plus 4 root 2 into x minus 3 root 2 over 2. Don't make me. 9 over 4, 9 over 2. So that's squared over root 2. So 3, yep, plus 4. So it's root 2 into x minus 3 root 2 over 2. I know I need to build up time as well. Minus 9 root 2 over 2 plus 4. P is root 2. R is 4 minus 9 root 2 over 2 minus Q is, so it's plus 3 root 2 over 2. Come on. So that's minus 6 root 2 over 2 is minus 3 root 2. So it's root 2 into 4 minus 3 root 2, which is 4 root 2 minus 6, which is F. Okay. Oh, God damn it. Okay, so here, let's draw this out. It's going to be so ugly. But that, and that, and that, and that, and that. And what I'm going to do is draw this line as well. Because if that's 55 and that's 40, then by angles in the same segment, if I slide that across, that whole thing should be 55. So that becomes 15. And that's that's a diameter, so that's 90 degrees. So that's 75 left for there. And then because that is an isosceles triangle, that in there is 75, which is E. Okay. Next, 25. 25. First three terms of a convergent geometric progression are that. So the common ratio, so we know that p minus 3 over 2p is the common ratio, but so is p minus 7 over p minus 3. So p squared minus 6p plus 9 from multiplying that up and squaring is equal to 2p squared minus 14p. So 0 equals, making sure the p squared stays positive, minus 8p from adding 6 across, minus 9, p minus 9p plus 1. So p is equal to 9 or minus 1. And then r is equal, maybe the r is the same in both cases. So r is p minus 7. So in other words, so p minus 7 is, let's take 9. So that minus 7 is 2. That minus 3 is 6. So it's a third. And if that's the case for 9, then the first term is 18. So it's 18 over 1 minus a third is 18 over 2/3 times 3 over 2 cancels. 9 is 27, which is G. I might come back and evaluate the other case if I have time. So I'll make a little, I could flag that in the real thing to come back to, but I wouldn't do it in like a second pass. I'd do that in a third pass. Some of the first 9 terms is a common difference. So it's 9 over 2, 2a plus n minus 1d, which is 9 into a plus 4d. So that's the sum of the first 9 terms, plus the sum of the first 10 terms, which is 5 into 2a plus 9d, which is 10a plus 45d. So 19a, 36 and 45 is 81, is equal to the sum of the first 11 terms, which is 11 over 2, 2a plus 10d. A5 is 11a plus 55d. So 8a is equal to 55 minus 81. So 80 minus 54, well, no, it just 6, 7, 2, 26 minus 26d, minus 26d over 8, minus 13 over 4d, which is A. Okay. (21). That is a factor of that. So that means that x minus 3 and x plus 2 are factors. So if I plug in both x equals 3 and x equals minus 2, I'll get 0. So let's plug in x equals 3. So 27, let me zoom down. So 27 plus 9a plus 6 plus b is 0. So 33 plus 9a plus b is 0. Plug in minus 2. I would get minus 8 plus 4a minus 4 plus b is also equal to 0. So minus 12 plus 4a plus b is 0. Let's subtract that minus that is 45 plus 5a, that minus equals 0. So 5a is minus 45, a is minus 9. So minus 36, so minus 48. So b is equal to 48. And a plus b is equal to 39, which is h. I have not time. So okay, let me go back and do this first question. So let's see if I can get it done in a minute, which is all that I have. So I have circle, greatest possible value of that. So that would be if 2x plus 3y is equal to a, then y is equal to minus 2/3 x plus a over 3. So that's a over 3. That that's 1. Unlikely to get this done in time, so let me take a good tactical guess. I have 20 seconds. I'm seeing roots, 13s. I'll go for G. Why not? 5 seconds. No shame in that, because I was doing good work the whole way through, but that was the point of a multiple pass system. It means that I know that the question that I didn't have time to finish was a question I didn't really like anyway. Ideally, now this one I am going to go through the answers and then the splits, because I have a feeling I should have done that differently in terms of my passes. Okay, so let's just see how that came out. So I started here on 37. 37, I got B. 35, I got A. 33, I got C. 31, I got E. And you can even just look how much work there is there. I should probably not have done that one. And there's probably even a faster way. 31, I got E. 29, I got F. 27, I got E. 25, I got G. 23, I got A. 21, I got H. And then 39, I guessed sheer dumb luck. This is why you guess. So I got full marks. Didn't deserve full marks, but I got them. Okay, so let me go in now, do 39 properly. So let me continue on where I was. So it's a circle of radius 1 centered on the origin. I definitely rearranged that correctly. So the gradient is minus 2/3. Okay, sorry. What I should have spotted, that's perpendicular. So the gradient of this line is going to be 3/2. 3/2, and the hypotenuse is 1. Well, if the gradient is going to be 3/2, it's a scaled up 3/2, and that would have been root 13. So in order to scale it, we'd scale it to 1, 2 over root 13, 3 over root 13. And these are similar triangles, because if that is alpha, then that is alpha, that is 90 minus alpha, that is 90 minus alpha. They have all the same angles, so they are similar. So the triangle 1, 3 over root 13, and 2 over root 13 is similar to this big triangle, which has hypotenuse a over 3, and once that, if that is the alpha, and that is the alpha, then the long side here is 1. So to go from here to here, I multiply by root 13 over 3. So 1 times root 13 over 3 is root 13 over 3, which is equal to a over 3. So a is equal to root 13, and a was this maximum alpha. So I got real lucky there. Let me work out where I could have done a time save, because that's the first time I've never actually gotten to the end. So let me go through my split times so I can adjust my strategy. Skipped it in 8 seconds. That was good. Solved this in a minute. Solved this in a minute. Solved this. Yeah, this was 1:41, which is fine to be a little bit over, but this was 2 minutes 43. So what should I have spotted? What could I have spotted? So I had the right idea. But oh, God damn it. All right, they got me. Okay, so here's the faster path. I should not have, I went so the wrong way around here, because I shouldn't have rationalized this denominator, because I should have realized that it was going to cancel. That was silly exam strategy of me. So what I should have done is to have spotted, well, in fact, let me get to the other pen. I should have spotted that. That was going to come and turn into 2 over 3 minus root 5 into a third of 3 minus root 5 cubed, which would have canceled 1 to make it squared. So it's just 2 over 3 into that thing squared. So 9 plus 5 is 14 minus 6 root 5, which is 28 minus, oh, that would have been okay. So lesson there, do not do more work than you need to. So only simplify things at the point at which you must simplify the thing. So I see this a lot with students who see, I don't know, they do 38 times 52 over 16, but then they later have to, and then you later do something, and then it actually all cancels down. And then you go, oh, so instead of actually calculating them, which would have taken ages, leave it as it is, and then maybe it cancels down later. I should have applied that same strategy. I should have applied that same strategy here. I should not have rationalized that in case it canceled, because it would just added time. So that would have saved me so many seconds, and then I would have been fine. So that it's not that it was a bad first pass question. I just didn't employ good exam technique there. So let's move along. So then it was 134, 55. I want to explain. Well, no, let's just do the splits. 140, 131, 126. Yeah. So all my other splits were fine. It was just that. And the lesson there is don't do anything you don't have to do until you have to do it. Do I want to explain any of the actual math in a bit more detail? This was just canceling ad infinitum. I just knew it was going to take too much time to do Pascal's triangle on that, so I didn't bother. So I knew I could use the factorial form and that things would just cancel indefinitely. I put the 4 2 squared to make that 2 to the 8 because I knew it would cancel a lot better. So that worked out well. This, yeah, just brought it together and did the stuff. That wasn't too bad. This wasn't too bad. This wouldn't have been too bad. Always completing the square and just being really diligent. So this worked. This is one I definitely want to spend more time on. So I know if I kind of draw a straight line-ish, I haven't paid for the upgrade to allow me to draw actual straight lines. But here, so these become angles in the same segment. So I know that I'm looking at that and like they're both pinned by those 2 points. So if I keep my thumb sort of pinned on that, I can slide the other point anywhere around the circle and the angle will be the same. So that's how I knew this total angle would be 55, which is why that internal one would be 15. And then that being a right angle triangle gave me the 75 left here. And then knowing that that was isosceles. So it all hinged on you knowing to draw that line. Because otherwise it just would have been impossible. So you either kind of spot that one or you don't. And if you were sitting there like for more than 5 seconds trying to think of something, pass. Anything else that needs explaining? Nope, just this is a classic from your textbook. You've seen these. You have to find the ratio 2 ways and then solve. Well, actually, while I'm here, let's analyze this because I have a feeling if I'd done the one case, I would have gotten -2 as my initial, and then I would have gotten -4 and then -8. Oh, that might have been even easier because then the common ratio is just -2, and then it's a over 1 minus r. That really would have done it. Oh, but that's not right. Oh, I'm an absolute flaming idiot. Because that's -2, so that's not convergent. I got lucky there. Oh, I got lucky. So, okay, I should have actually checked what the common ratio would have been in both cases. Here, because the common ratio has a magnitude bigger than 1, it's not convergent. So I just got lucky that the first one I tried happened to be the convergent case. Good to know, but luck is luck and I'll take it. 23, this was just doing it. And then 21, this was just doing it. Really, nothing much there. And I've explained this one. All right, so let's move back over and we'll do the physics. And let's start the clock. This one, absolutely not. This one, I don't like it for a first question. This one, I also don't like that for a first question. This one I can do. There we go. That's how you do find your first question. Right. So here, that's positive, that's negative, so the current's going around. So here, the left-hand roulette, the current is going down, the field is going left, so this force is out of the page towards me. This is out of the page into the page, so it's going to rotate like that. So it's going to rotate about that vertical line. So for 37, it's going to rotate about an axis. It's in the plane of the page and perpendicular to the field, so the answer is H. Okay. So here, I'm not going to fall for this again. So the average speed of a particle in the string. So that's what it does is in one full oscillation, it moves 3 up, 3 down, 3 down, 3 up. So it moves 12 centimeters per cycle. So V and the time period. So 12 centimeters and the time period is 1 over 12. So speed equals distance over time, which is 144 centimeters per second, which is D. So here, so just want to check I'm good on, yeah. So here, thin piece of glass, 10 more complete oscillations compared to that, speed of light, so it slows it down. Right, so V equals F lambda. I know from refraction the frequency doesn't change, these go proportional. So I know that the lambda goes to 2/3 lambda in the glass. And I know that the thickness T, so the number of wavelengths in the glass is the thickness over that wavelength in the glass. So that's the number of cycles. And that number of cycles is 10 more than this. 10 more than the same thickness and the same wavelength. So there are T over lambda number ones in air. So what's the thickness of the glass? So 3T over 2 lambda equals, let's call this 2T over 2 lambda plus 10. So T over 2 lambda equals 10. And thickness is 20 lambda. So that is E. Okay. I normally like these. But this is multiple, and I would need to work this out. So let's pass this one. Let's come back to it. I absolutely adore latent heat. So let's go for it. So here, equilibrium. So 10, so what's going to happen is the energy going into the ice is ML plus MC, and it goes from 0 to T, so the delta T is just the T it ends up on. And that equals the MC delta T, which is 30 minus T, which is the tangent temperature of that dropping. We're going to divide both sides by 10. So 330 plus 4.2 T equals 8.4 into 30 minus T, which is 84 times 3, which is 252 minus 8.4 T. So 12.6 T equals a negative number. So the temperature would be negative something, which can't happen, which implies to me this doesn't finish. So it hasn't finished melting. Like when the energy lost by the time this drops to 0 is not enough to fully melt the ice. So the stuff stays at 0 degrees, and that's B. Here, to equilibrium. Right, so what I know here is metals are good conductors, so I would expect it to be roughly the same temperature the whole way through. And I know that the insulator is able to maintain a much bigger temperature gradient because that's the whole point. Like the hot liquid on the inside and the cold air on the outside, it can maintain that temperature gradient. So I would expect a big temperature gradient in the insulator and a small one in the thingy. And that, but I wouldn't expect it to be a step function like that. I think it's A on that basis. It's just using my sort of day-to-day stuff. Okay. Okay, so this one, the other stone is released and falls under gravity. So what I know is the first stone is released, and so it has some speed by the time the second is released. But at that point, both of them are accelerating together. So I would expect there to be, I would expect there to be a common relative speed between the two. So I would expect the separation to become linear and increasing, but I would expect it to start by s equals ut plus half at squared. I would expect it to start as a quadratic. So that is A. I'll have to explain a lot of this later. But in the interest of time, nope. So 30. Half-life 2 days and 3 days. Both of them decay in a single step. So initially, let's do my little ratio trick. So initially, it's 2 to 1. After how many days would they be equal? Well, that's the trial and error. That's after 1 day, that goes to 1. Oh no, after 6 days, let's do every 6 days. So after every 6 days, because that's 3 half-lives, that goes to an eighth of the original, which is a quarter. And that's 2 half-lives, which goes to a quarter, and that just happened to work. So I'm going to take it. 6 days, E. Now this one, no. Just no. I don't know what they're playing at. No. I'm not up for the shenanigans. This is first run. I just want the easy marks. Be lazy. Just area and volume of that. Right. That means that the height or the length is equal to 15. Yes. Bar rests on a horizontal surface on one of its circular faces. Pressure on the surface due to the bar is that. So the force is pressure times area, which is 4.5 times 1.2, which is 9 over 2 times 6 over 5. Cancels for 3. It's 27 over 5, which is, I don't know, 5.4. Newtons. Therefore, 0.54 kilograms. Therefore, 540 grams over 180 centimeters cubed. Let's cancel for 9s and equals 3, which is B. Okay. Keeping it nice and calm. 27. Nuclide of element X. Double the nuclear charge, which means it has 4 protons, and 4 times the total mass. So the total mass was 5. It is now 20, which means there's... Oh, no. That's the mass number, so 12. It decays by a single beta emission, so it's going to go to 12.5 Z. which is E. Okay. Here, spring is unstretched. Oh, hold on, let me, just in case there are more comments. Okay, so spring is initially unstretched. So we know that 0.015 is a half K times x squared in meters. So in other words, the extension is 0.05. Let's 1, 2, 3, 4. So 150 times 25. Cancels for 6. So 12 is equal to K. So F is equal to K X 005 2400 over 10 to 40. No. But I'll take an initial guess that it's E because I've done something silly. Oh, I can do the spring constant instead. Whatever, I'll come back to it. If I have time. In fact, I might even make a note of that to come back to 26. Okay. So here, I'm going to take a split time. Car travels. I know I don't like speed, but I actually like this one, I think. Total time of 20. And the average speed for the whole journey is 8.5. So the total distance is 20 times 8.5, which is 10 times 17, which is 170 meters. For the first t seconds, its speed is that. So 170 is 5t. And 10 into 20 minus t. And we just solve for t. So 5t, 200 minus 10t. This is going to be completely fine. 5t is 30, and t is 6, which is B. Okay. Okay. Simple circuits. So we know that they're imperfections, but I'm just trying to rack up the score as much as possible. All three resistors are identical. Okay. So when the switch is open, the reading on the ammeter is 1, and the power is 1 watt. Okay, I am actually going to have to right. So when the switch is open, that is 1 amp and 1 watt. So the voltage is 1 volt. So that is a 1 volt battery. And the resistor as well as 1 ohm. And these are all identical resistors. Yes, so that's also 1 ohm. That's also 1 ohm. The switch is closed. This is still 1 volt, still 1 ohm. So that's still 1 amp. 1 volt across this, 0.5 volts on each. V equals IR, so that's 0.5 amps in there. What do I actually need? So that A stays 1. Oh, and P is I squared R. So that power is still I squared R is 1. This is I squared R. That's a quarter. That's a quarter. Total power is 1.5, which is F. Okay. So here, another circuit. 23. Variable resistor is adjusted until the reading is that. And the resistance of the heater is that. So variables. So the current is 5 and the resistance is 8 ohms. So V equals IR. So we know that's 4 volts. Oh, that's fine. So energy in 5 minutes. So we know that a volt 4 is work done per unit charge, but Q is equal to IT. So the energy is going to be 4 times that times 5 minutes. I just got to get a number for that. So let's call that 5 and 6. So that's 20 times 30, which is 600, which is D. Okay. 22. Spaceship of that is moving at that relative to the space station. It's captured, brought to rest by force. So this is going to be momentum. And I'm not going to fall for it this time. Right. So the resultant force is the change in momentum, which is 20,000 all over time. But let's say that's the only result in the force, so let's call it 1,000. Cancels, cancels. So T is 20 seconds. How far will it move in its initial direction? Well, acceleration is 10. U is equal to 2. And S is equal to UT plus a half a t squared, which is 60. No. I don't know what's happening here. It's not first pass. I'll come back to 22. Okay. Don't know why I'm struggling with something that early in the paper, but whatever. It's not first pass, so I'm not even going to stress about it. So here. Weight W on the moon. So W equals mg moon. Moon has no atmosphere. Object is released from rest. Height h. Right. So the acceleration is W over m. So V squared is U squared plus 2a s. I should really have done that just from energy, but whatever. So the speed of the object is the root of 2wh over m, which is g. Okay, first pass done. Let's go mop up some extra points. And I have about 11 minutes left. $40. Volume of gas is that. Does not change. Okay, so P1 V1 is P2 V2. So down here, pressure down there times the volume of 90 is atmospheric pressure. I'll call atmospheric pressure P times 720. So the pressure at that depth is equal to 8P. So the differential, so the extra pressure due to the water is that. And I know that the differential is rho GH, so it's proportional to H. So at a depth of D over 2, delta P will be equal to 3.5 times atmospheric pressure. So the total pressure will be 4.5 atmospheric pressure. So I'm going to, that times the new volume will be equal to P times 720. Cancels, cancels. The new volume is 720 all over 4.5. 45 add a 0. 9s on that give me 8. 1600 over 10, 160, which is A. Okay. I didn't do this one. So it's a floating block of wood, which was balanced until it was displaced downward, which introduced a new upwards upthrust of. Now, upthrust is the weight of water displaced. So which is the density of water times the volume of water displaced, which is, and that cross-sectional area is L squared. So L squared times that distance drop. So that's L cubed over 10. So density times volume is mass times G is the net force. And that force equals the mass of the whole thing, which is density times volume times A. Cancels, 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 cancels for 1. So the acceleration is just 1 over 0.8, which is 1 over 4/5, which is 5 over 4, which is C. Okay. Haven't done this one yet. Okay, so going through. Yeah, that's enough. Okay. So I've got a bit more time. I've still got over 8 minutes left, so I'm feeling calm, feeling good to go. I know I've got a couple to come back to, but that's fine. Battery X, Y. Power transferred is 6 watts. The resistance of X is, so that's 10 ohms. That's 4 volts. And I know that this voltage, what's the current? Yeah, let's do it in terms of voltage. So this voltage, if that's R, is going to be 10 over 10 plus R. So that proportion of the total resistance. No, let's do it as so what I know is that V1 over 4 equals 10 over R. So this voltage is going to be 40 over R. So the total voltage, well, and I know what am I missing? Total power is 6. Well, so the total voltage is 4 plus 40 over R. I'm going to come back to this. I'm going to mop up other things first. So I did that, did it, didn't do 34. Stepped up, and then stepped down. So this goes from 300 to 1500. So it's a step up of times 5. In the town, a step down reduces the voltage supplied. Reduces the voltage supplied by the transmission cables down to 33,000 volts for distribution to the town. The step-down transformer supplies a current of 1500 amps. The current in the transmission cables over here no, so that's 1500 over here. The current in the transmission cables here is 450 amps. And what is the voltage over here? I hate that ratio. What's 1500 over 450? Cancels, cancels. 10, 3. So it's a 10 to 3. And that's step down. So that's higher. So it's 10 over 3 times that. So it's 1. So divide that by 3 is 11. 110,000 volts in the cable. Voltage at the power station, so that's we have to divide that by 5. So it's 110,000 all over 5. Multiply by 2. Knock off a 0. It's 22,000 volts, which is C. Good. Okay, about 4 minutes left. Done it, done it, done it, done it. Didn't do it. Okay, let's have a think about this. I don't have a huge amount of time. I only got 4 minutes left. So I'm going to say, let's just make it so they rotate the same. So that has gone 45 minus theta clockwise. Let's also do this 45 minus theta clockwise, which is E. So 29. I'm going to write E. Okay, so, okay, 26. Why did I get that wrong? No, this is safe. This I can do. Maybe not under the time pressure, but this is certainly doable. So 1.5 times 10 to the minus 2 is a half times k times x squared, which is 25 times 10 to the minus 4. 1,500 times 10 to the minus 4. 3,000. Oh, I'm an idiot. Okay. Over 25, multiply by 4, 0, 0, 0, over 100, knock off 2 zeros. So k is actually... No, that's meant to be... So 0, 0, 300. 4. 1200. K is 12, not 6. And then F is equal to K X is 0.6, which is B. Okay. 26, 22. Let me look at my previous working. F equals change in momentum over time. So time is 20 seconds. Acceleration, F equals ma. It's 0.1. So it's 40. S equals ut plus a half a times t squared. What am I doing? A half a times t squared. 200. Damn, that's still 20. All right, we're into guessing territory. So I'm going to guess F there. What are the ones I didn't do? Did it? Did it? Okay, we're going to guess F on that one. 38F. And I think that's it. And I just ran out of time. So that wasn't great technique. And the real thing, I should have kept it, as I was getting into the end game, I should have kept a closer eye on the clock. Clearly, I struggled with that a little bit more. That was tricky, guys. That was tricky. So no shame on that. The way I would get around the psychological, well, I'll talk about the mental game later. Let's actually see how I did. So that's what I did in time. Now let's see what I can do with a bit more time and space. Ooh, I've gone way too far. Right. So that was bananas though. So 40 was A, 39 C, 38 I came back to. Did I actually skip all of that? This was all over the place. 34 C, 29 E. Is that all the working I wrote down? Where's all my stuff? Oh, I'm not at the. Am I? Oh, I'm being an absolute idiot. All right, I know. Okay. That's where I started. Apologies. 37H. Yeah. 36D. 35E. 33B. 32A. 31A. 30E. 29. I skipped for now. 28B. 27E. 26. I came back to. 25B, 24F, 23D, 22F, 21. Oh, how did I get that wrong? God, that's embarrassing. All right, let me do this using energy. What was my execution error? So weight W, so and release from height H. So the work done due to gravity is WH, and that equals a half mv squared. 2WH over m is v squared. I didn't do it again, did I? What am I missing here? Weight W. So the work done due to gravity is that, and that is half mv squared. Why is it h? 21? Oh, no, it is g. Oh, I did get it right. Oops. Okay, I'll take it. Great. So 40 was A, 39 C, 38 was that ended up being a guess. 34C, 29E, 26B. So everything I actually did, I got right. And then what was the one? I think I only had to guess 38 and I guessed F and I got it wrong, but whatever. All right, now that I've got the time, let me go through 38. Okay, so how should this have gone? So power transferred is 6 watts. Resistance of that is 10 ohms. Voltage on that is 4 volts. So it is certainly true. Let me look at what my previous working was so I can get a head start. What should it have been? It is certainly true, I think, what I said here. So the voltage ratio is the resistance ratio. So it is true that this is 40 over R volts. And by extension, well, yeah, and then this is R. So the current in the circuit, the problem I'm having is this R bit. So well, P equals I squared R. That's certainly true. And I can say, oh, I can also say that 4 equals IR. So R is equal to 4 over I. Okay, that's it. I squared into 10 plus 4 over I equals 10I squared plus 4I equals 6. So 10I squared plus 4I minus 6 is 0. Yeah, I can understand why I didn't get this under time pressure. So minus 15, so 5I, I. So it's going to be plus 1 minus 3. So I is 3/5 and not minus 1. So it should have been B. That's where that came from. Good to know. Okay, is there anything else I need to go over? So it's the only one I got wrong in the paper, so I'm pleased with that. This is a solid performance for me. I'll do performance review at the end, but now let me explain any of the physics I need to explain. I think there was a lot because I was taking shortcuts. This one, left-hand rule, I think this is pretty self-explanatory. I'll do it a bit slower though. So here, and I'll actually be able to write on the things this time. So here, the current, that's positive, that's negative. So current is there, current is there. So left-hand rule, current down, field to the left, pointing up towards my face. And this one, current is going up, field to, oh God. Current going up, field going to the right. This is going down into the page. So it's kind of flipping like that in this axis, which is in the plane and perpendicular to the field. This, it travels 6 down to equilibrium. Sorry, each of these is 3 from its max to the min. So the amplitude is 3, so it goes 3 to equilibrium, 3 down to minimum, 3 up to equilibrium, 3 up to maximum, which is where I got my 12 in one cycle. And then the rest of that, I think, was explanatory. This, did I explain it well enough? Not quite. So the thing here is distance. Well, the number of, so the thickness is the number of cycles times a wavelength. Which is where I got the idea that the number of wavelengths is equal to the thickness over a single wavelength. Ooh, so that's how I got to here. And then, so this number in the glass is T over this new wavelength of 2/3 lambda. The number of wavelengths in the air would have been the thickness over lambda by itself. And this one is 10 more than that, which is how I was able to rearrange it like that. So hopefully that makes a bit of sense conceptually. I skipped that one initially. This one, hopefully it makes sense that if this was true, and I kind of did this blindly, but if this was true, then the temperature would be negative, which can't be possible. So this scenario isn't right, and it hasn't fully melted and raised to a temperature. Hasn't fully melted at all. Let's work that out in a bit more detail to demonstrate it. This is how I would have done it in the real thing, but now we've got the time. Let's actually go through. So here, MC delta T to get to 0 is 8.4 times 30, which was the 252 joules to get to 0. But Q, it's 300. I think there's a 0. I missed a 0. Maybe I didn't miss a 0. MC delta T Oh, yeah. That's 84 times 30. So I did miss a zero. So it was 250, that many joules to get from 30 degrees down to zero. And here for 10 grams melting, ml is 3,300. So you haven't even fully melted it yet. So it's still at 0 degrees. So that was true. This, oh, I can definitely need to explain that one a bit better. So here, how do I explain it without using the thermal conductivity equation? I don't. So let me show you some new physics here. This may help in certain situations. So there are other questions which look similar to this. You have this equation. The rate of thermal energy transfer is the thermal conductivity times the cross-sectional area times the temperature gradient. So if you want to increase the rate of energy transfer, you make it more conductive, you increase its cross-sectional area, or you increase the temperature gradient. Here, energy cannot be created or destroyed at the boundary. So let me just scroll up so you can see it. So therefore, the rate of energy transfer into the boundary equals the rate of energy transfer out of the boundary. And they have the same cross-sectional area. So what that means is K1 times the initial temperature gradient is K2 times the second temperature gradient. And here, because the thermal conductivity in the insulator is so much less than the conductivity of the metal, in order for them to be the same, the temperature gradient has to be so much bigger in the insulating material, which is why it's A. Or you can use my kind of loosey sort of brute forcing it from real world understanding. But the idea is because it's a conductor, it's going to be much more even temperature all the way through, whereas insulators are much more capable of maintaining higher temperature gradients. And here I can also do this in a bit more detail. So here, I think it's self-explanatory that S equals UT plus half AT squared, which is why initially it should start off like a nice quadratic, which leaves you with only 3 options. So it's either going to be A, G, or H. And actually, between the two, it's quite obviously going to be A because they are still going to get further apart. But to convince you that, so let's say the first stone has reached a speed V by the time of the stone's release, the second stone's release. So for the first stone, we can sieve at it. It's going to start with a speed V. It's going to have G. And for the second stone, it's going to start with a speed of U and have a speed G. So for time T, and we can compare the S's, then the distance between them, no, let's not do that. Let's do the speeds. So this speed is going to be, well, let's give it a U. It's going to be U plus GT. And this speed is going to be 0 plus GT. So the relative speed between them is just going to be U. In other words, whatever speed it had at the time of the second stone's release, that is a constant relative velocity between the two stones. Which means that the separation between them is just going to be this relative speed times time. Or in other words, actually, how is this relative velocity represented on a distance time graph? The gradient. So the relative speed is constant, so the gradient is constant. If we were in person, you'd be able to ask questions, and hopefully I'd be able to answer them, but that's kind of how I understand it for now. This, I got lucky. It worked. I'm not going to complain about it. The end. This, I hate this question. Is it even worth me explaining it from first principles? If you wouldn't get that in 90 seconds, I've got time, I may as well. So here, if it was like that, let's compare them before and after. So this would have been 45 from the normal, so this would have been 45. And they were parallel, so they have the same normal, so this would have been 45. And of course, I should not have even done that because it's relative to the normal, but it's still 45. So that's 45, so that's still 90, yada, yada, yada. Here, to the normal, that is theta, so that becomes 90 minus theta, and that becomes 90 minus theta, which means that if that is parallel again, that becomes 90 minus theta, that becomes 90 minus theta. Does that explain it? That does not explain it. That does not explain it at all. Well, I suppose then that whole thing is 180 minus 2 theta, so that becomes 2 theta. And then you can argue that the sum of those is 180, which means these are co-interior angles, so these are parallel. So that's how I would do it generally. I would never get that done in 90 seconds. But that, and again, that only works if that is theta and that is theta to the horizontal. In other words, the same thing, which requires them both to rotate the same way. So this was an insane question. Insane question. So second pass it, tactical guess. Like, no shame about that. This, I think I got pretty easily. This was fine. This was fine if I could do math. This was fine. This, I think I explained it okay. This was fine. I think I guessed this. Why did I keep getting this so wrong? All right, let me do this properly. It's moving at 2 and it's decelerating. Oh! Nah! Literally right there, I just answered my own question. Oh, that was silly. Come on. A is minus 0.1, so that becomes minus 20. So it's 40 minus 20, which is 20. That was just silliness on my part. Just silliness on my part. And this I got right. Okay, so that's conceptually what happened. Let me check my strategy in terms of splits. So I won't go through the questions, but I will go through my answers. So a 4-second skip, a 6-second skip. Did I actually? Well, actually, I'm going to have to look at this. It's 37. Did I actually answer that in 7 seconds? Oh, because I skipped that one as well. So 3 skips, 3 quick skips. This one I got in 38 seconds, then 5 seconds, 1 minute 26. 34, did I skip the first time? Yes. I skipped that in 20 seconds. 33, I got that done in 1:34, so pretty good on time. Then 1:14, then 46 seconds, 57 seconds, a 5-second skip, 1:30, so bang on the money, 48, 1:53 on 26. Yeah, I was messing that one up badly. Okay. That shows in the split times. then 52, then 134, which is still fine, then 113, then 123, then 120, and then I get into the second pass. This was 130, this was 118, then 154, and then the split times just go bananas as I don't even know where I was running to. But then and that's a proper second pass, is then I was having to think a lot more and take a lot more time. Okay, so that's the actual paper. Let me do some sort of self-feedback. So as I think about that, the score I got was much better than this. If you just watched my stream and how I was doing it, the score you'd think I would achieve is a lot less than what I just did. So I got full marks in math 1, full marks in math 2, and 1 mark off in the physics. But if you looked at how I was struggling through that, you would not give me those scores. So what is it that I did that allowed me to struggle but still score? The first thing is just, hold on, let me just, I maintain, this is why I have the multiple pass strategy. I told myself at the start I was going to stay calm and I was just going to move through it, try and pick up the marks where I can. Here's what I didn't do. Here's where I could have gone wrong. So let's look at that physics, for instance. I skipped the first 3 questions, and then I was getting a bunch wrong in the first pass. It would have been really easy for me to think, oh God, this is going so badly. Oh God, this is going so badly. But I didn't. I went, this is a first pass. The first pass is just picking up quick marks. These are my bonus marks. This is just marking things safe. So I went, let's just go through the first pass. And then in the second pass, I was able to mop up some extra stuff. And that was the same the whole way through. So I know how my pass system works, and I trust that system. I trusted myself to keep calm as well. I was like, panicking is not going to help me. This is a mark getting exercise. So whatever state of mind I have to be in to get the marks, I'm going to be there. So I kept it calm. I kept it smooth while keeping my foot on the gas. So fast and smooth is the way to go. What else really mattered? Think about the first question I picked was really important for setting the tone and making sure I was like, this is going to be a good run. There was something else I was thinking. Let me see if I can find it. Yes. So there were ones that I had to guess. This is the first time on stream I've not actually made it to the end, and I've had to guess because the time management wasn't great. How do I feel about that? Completely fine, because of the multiple pass system. I know that every second spent was spent on a good question where I had a high probability of getting it right. So the fact that I had one question at the end of those that I had to guess, I'm not mad about, because I know that what I did was good work that I don't regret. And so by using that technique, I'm able to walk out of it with no regrets and think, oh, it's because I was never going to get that question in time. Cool. And that's really what you want for yourself, is to walk out with no regrets, knowing that the time you spent was time well spent and you showed your best work. I look at that, I'm like, that was the best I was going to do in time. And then, yes, if you had more time, you would be able to go through it more slowly and you would have got them probably all right. But you didn't. You only had the time that you had. And so by using the technique, I got all the marks that I could get. And I'm not going to panic because I'm going to compare myself to everyone else. Everyone else is in exactly the same boat as me. I'm thinking that paper was hard, so everyone else thinks that paper is hard. And I know that everyone else doesn't have the same limitations on time that I did. So if I'm not showing my 100% best work, well, neither is anyone else. And so for me, I would look at this run and think, all right, that was a tough paper, but that felt okay. And then when I got my marks back, I probably would have got straight 9s on those. So I'm happy with that. And hopefully watching me go through that, A, validates the struggle because 2023 was difficult, and B, shows how you can apply this robust multiple pass technique to keep your head and just trust the system and get every mark, because you're not aiming for perfection. You are aiming to get out of yourself every mark that you possibly can. I didn't achieve perfection, but I did get out of myself every mark that I possibly could given the run. finding myself in a situation where I was making mistakes, I didn't get bogged down. I skipped and then came back to it. Given a situation where I was faced with questions I knew I just couldn't handle, skipped them. Didn't let them bring me down. I went and got all my good marks. Given a situation where I was staring at the clock with like 10 seconds left and I had guesses to make, I made sure to get all of my answers down. And while I'm there, by the way, that's another reason why, and I nearly didn't make it back, which is why you really want to guess and flag and skip on the online version, because if you don't have time to come back, then you wouldn't get anything done at all. And you saw on the math too, I guessed randomly and I got it right within the time. So I think there's a lot of good stuff there. I think you get a lot more from it when I'm struggling and you watch how I get through the struggle or just learn to cope with the mistakes that I made. So hopefully there's enough for you to sort of pick this over in the final day. I know the ESAT is tomorrow and Friday, so hopefully you find this useful. I'm going to wrap here. I don't want this to be too long for you. So I'm just going to say all the best in the paper. Do what I just did and show your best work, and don't walk out thinking if you got it wrong, then it went badly. Just try and get every mark that you feasibly could in the time. Walk out with no regrets, and then you can't regret the result that you get because you'll have shown your best work. So with that, good luck, work hard, have fun, and I will see you on the other side.